So to find the expression or the relation between coefficient of linear expansion, which is alpha, what would be the beta? As I told you, gamma was coefficient of linear expansion, the beta would be coefficient of area expansion, and third, gamma coefficient of volumetric expansion, right? So now we have to find a relation between alpha, beta and gamma. Okay, for that what we are doing, consider a cube. You can start writing, consider a cube of length L, right? So the area would be L square and the volume would be L cube, right? Okay, so we have to find a relation between alpha, beta and gamma, right? Relation. What we have considered a cube of length L. The area of any face, any surface would be L square, right? Initial length, area and volume would be L square, L cube. This is true. Now suppose initially temperature was T1 and finally temperature is T2. Suppose there is delta T change in temperature, due to which there is a small increase in length, that is the final length becomes L dash, which is delta L plus L. That would be the final length, change in length plus original length. Similarly, area would be area plus change in area, and volume would be original volume plus change in volume. So what has happened now? We have increased its temperature, due to which there is a small increase in length. So final length would be delta L plus original length. Then similarly area would be delta A plus original area, and volume would be delta V plus original volume. This is true. Okay, let's find out a relation between first alpha and beta, that is we are relating length and area dash. What is new area dash? That is L dash square. Original area was L square, so A dash is new change in length square. A dash is what? A plus delta A. L dash is L plus delta L square, right? What was delta A? See, writing the values, if I have to write the value of those three formulas I just wrote, what were they? Let me derive it out. Delta L was proportional to L and delta T, so delta L is equal to alpha L delta T. So that means delta A would be equal to beta A delta T, and delta V would be equal to gamma V delta T. These are the three formulas which I am looking for. So putting this value of delta here, I'll get A plus beta A delta T is equal to L plus delta L whole square. L plus, instead of delta L I am writing alpha L delta T, right? This whole square. Now if I take A common out, I'll be getting 1 plus beta delta T, right? This is equal to, if I take L common out from inside the bracket, I'll be left with 1 plus alpha delta T, right? This thing is whole square, or I'm putting the square thing inside, it will be square here and square here, right? So the outside is gone. Or A is equal to L square, so you can cancel out these two terms. So now we are left with 1 plus beta delta T is equal to square of 1 plus alpha delta T square. So just pour the formula and expand it according to formula. It will be A square plus B square plus 2AB, twice 1 into alpha delta T. Now the value of alpha and delta T are both so small that the square would be even smaller value, right? For example, we have a quantity 0.1. Square of 0.1 is 0.01. So any square of smaller quantity becomes much smaller. So we have to eliminate this term because this is negligibly small. So all you are left with is 1 plus beta delta T. This is equal to 1 plus 2 alpha delta T, right? cancelling out 1 and 1 from both sides, I'll get beta delta T is equal to 2 alpha delta T. Again delta T and delta T are gone, change in temperature was same for each. Beta is equal to 2 alpha, that is the relation. Similarly, as I did this expression, same ways you can start with volume is equal to L dash cube, and then instead of V you can write here V plus delta V, and here you can write L plus delta L whole cube. Expand it, take the common out, do everything same, and at the end you will get gamma is equal to 3 times alpha. So basically here what do I get? Alpha is equal to beta upon 2. Here I get alpha is equal to gamma upon 3. So the relation is alpha is equal to gamma upon 3. This is the required relation which we are looking for.